So starting with binomial, right? Binomial theorem. Why binomial theorem is used? What is the use of binomial theorem? So basically it is about finding out the values, finding out the terms in expansion of a bracket. In expansion of a bracket, and during that expansion, sometimes we will go with all the terms. Sometimes we go with like that, okay, what is the fifth term, any specific term with term number, or we go with any coefficient of a variable with some power. So these are the things which we solve by using binomial theorem. Okay. So first of all, what I'm going to do over here, for instance, you are having a plus b whole power 0. Okay, a plus b whole power 1, a plus b whole power 2, a plus b whole power 3. Okay, first of all, you have got this one. So when I will expand this thing, this will be a plus b whole power 0 will be equals to 1. Power 1, that will be a plus b. Power 2a square plus 2ab plus b square. Okay, a cube will be a cube plus 3a square b plus 3ab square plus b cube. Okay, these are the things which we will do when we are having expansion. Now the first thing you can see over here, power is 0, number of term is 1. Power is 1, number of terms are 2. Power is 2, number of terms are 3, and power is 3, number of terms are 4. So it means in an expansion, comma, number of terms will be equals to n plus 1. Okay, the number of terms which we have to get after expansion, that will always be equals to n plus 1. That is the first thing I am giving you over here. Okay. Now I have got an expansion over here of a plus b whole cube, which is a cube plus 3a square b plus b cube. Okay. Now inside the bracket, power is 1, whole power is 1. Okay. Outside the bracket, for each term, if you are going to add their powers, like what is the power over here? Power is 3. What is the power over here? A square and b power, then a power 1 b square and then b cube. All of them are sum up to 3. This is 3. 2 over here, 1 over here, add up to 3. 1 over here, 2 over here, add up to 3. And this is also going to be 3. So we can say that in this type of expansion, the total power over here will be equal to sum of these powers. But what is the important thing? First of all, inside the bracket, it should be 1 and 1. Only then you can do it. Okay, so it is not a general rule. It is just a small trick which I am telling you over here. Okay. So now, with the help of this example, now I am going to write a general formula over here. What is that general formula? The general formula of binomial theorem is TR plus 1 NCR A n minus R and b to the power R. Okay, this is my general formula. Now we are going to simplify it, and we are going to, now I'm going to explain you what is the each term expressing over here. Okay, first of all, n is expressing whole power on the bracket which is supposed to be expanded. Okay, in this case it is 3. N will represent whole power of the bracket which is to be expanded. Okay, first thing. Now A will represent first term in the bracket which has to be expanded. B represents second term of the bracket which has to be expanded. Okay. Now, what is the power of A right now? The power of A is written n minus r, and power of B is written r. If I add both of them, power of first term was n minus r, power of second term is r. If I will simplify them, so the result will be n minus r plus r. This will be cancelled. So the result will be equals to n minus r plus r. The result will be equals to n. And what was n? N was the whole power which I have told you over here. So in each term, if you will add the power of the given variable, it will mostly equals to the given whole power of the bracket. Okay, not in every case, but mostly it will happen. Okay. Now after this, uh, I have explained you that n will always represent whole power. A is first term, B is second term. Okay, these things I have explained to you over here. Now let's write this thing over here and compare it with this one. This thing NCR, the combination thing that we will do when we are going to work out with unknown powers. Unknown whole powers is given. So let's write these things. A cube b power 0 or a square b power 1 or a b square or a to the power 0 b cube. Okay, they are written in a pattern. The first term is having descending powers and the second term is having ascending powers. See over here. The first term is having descending powers and the second term is having ascending powers. Now, let's compare it with this one. See, a n minus r b to the power r. So, okay, which term is this one? I haven't written my coefficient right now. I'm not talking about the coefficient. I'm just talking about the variables right now. So, this is my first term. Okay, this is my second term. And this is my third term. And this is my fourth term over here. Okay, this is my fourth term over here. Now, if I will compare it with this one, a n minus r b to the power r. See, what's b over here? B to the power 0. So it means in this term, the value of r is equals to 0 if I compare it with this thing. R equals to 0 because b to the power r is the part of the formula. So b to the power r and b to the power 0, it means r is equals to 0 in this one. Okay, let's talk about this one. I'm not talking about this one right now. I'm just talking about this thing. B to the power 1, b to the power r, it means r is 1 over here. In this one, r will be 2. In this one, r will be 3. Okay. When I'm comparing it with this one, I have written what will be the value of r for this term, for this term, for this term, and for this term. Okay, that I have written over here. Now, let's compare it with something else. First term, r will be 0. Second term r will be 1. Third term r will be 2. Fourth term r will be 3. What does it mean? It means the value of r will be always one number lesser than the term number. If first term, r will be taken as 0. If third term, r will be 2. If I'm talking about fifth term, r will be 4. If I'm talking about seventh term, r will be 6. In this same way, if I'm saying the value of r is 8, what will be the term number? You will say, okay, 8 plus 1, term number will be 9. If I'm saying r equals to 17, which term number? R plus 1, term number will be 18. So see, over here I have written what? For term, any term, it will be always R plus 1. Where R is what? R is 1 minus term number minus 1. R will be always term number minus 1. If it's fifth term, R will be 4. If it is 17th term, R will be 16. Always one number lesser than your term number. That thing will represent your value of R over here. Okay? Of question number 3 of exercise 14.2. Okay. The question says that obtain in ascending power of x, in ascending power of x, I have to find first four terms of 2 minus x over 2 whole power 7. Okay, they are saying that I have to find in ascending power of x first four terms of this expansion. Okay, so as they are asking for ascending power of x, so the higher power of x variable should be written on the second term position. If we need ascending power of x, the higher power of variable x should be written in second term position. And if they will ask for ascending power of x, then what will happen? Then it should be written at first term position. The higher power of x will be written at first term position. Okay? So as they are asking for ascending power of x, my higher power of x is written at second position. So the things are okay with me. Now formula TR plus 1 equals to NCR AN minus R B to the power R. Okay, that's the formula. So I need first four terms. So T1 N will be 7. C R will be one number less than term number. A, that is 2. N minus R means 7 minus 0. B will be minus x over 2 whole power 0. B is minus x over 2 and this is power 0. So this is there. Okay. Now when I am going to simplify it, 7c0 will be 1. 2 to the power 5 will be 2 to the power 7 will be 128 and this will be equals to 1. Okay. Simplifying it, my T1 value will be equals to 128. That's my first answer. Okay. Now I'm going to go for T2 term. Second term, again, the formula will be used, which is this one. This formula will be used over here. As I have used it over here, I'm going to use it for second term, third term, fourth term, all will be used by this formula. Okay. So T2, 7C 2, 7 minus 1, minus x over 2, power 1 will remain. Okay. Now what we are going to do, first of all, 7C1 will be equals to 7. 2, 7 minus 1, power will be 6. 2 to the power 6 will be equals to 64 into minus x over 2. Okay. Now, simplifying it. So when I will simplify it and divide it by 2, my answer is going to be minus 224 x. Minus 224 x. Okay. Now, the third one. This is my T2. T3. 7C2 into 2, 7 minus q into minus x over 2 whole square. Okay. This I have got over here. So now, when I'm going to find the value, 7C2 will be coming equals to 21. 2, 7 minus 2 will be 5. 2 to the power 5 will be 32 into minus x whole square will be x square over 4. Okay. So when I will simplify it, this answer is coming 168 x square. This answer is coming 168 x square. Last term, as per requirement of the question, not according to the extension of this thing, as per requirement of the question, last term is T4. What will be T4? T4 will be 7C, this is 4, that will be 3. 2, 7 and 3 is written, 7 minus 3. Then minus x over 2, r is 3, so that is written 3 over there. Okay. Now, 7C3, result will be equals to 35. 7C3, the result will be coming equals to 35. 7 minus 3, power will be 4. So 2 to the power 4 will be 16 into power is odd, minus sign will remain, minus x cube over 8. Minus x cube over 8. When I will simplify it, so 8 1s are 8, 8 2s are 16, 35 into 2 will be 70x cube of minus. Okay, so I have got all 4 terms which are needed. I am going to write it over here, beta. First one is 128. Second one is minus 224x. Third one is 168x square minus 70x cube. But there are more terms which we don't need, so I have put it these dotted lines. Okay. In B part of the question, they are saying find value which is approximate value. Okay. Find value of 1.995 whole power 7. I have to find the value of 1.995 whole power 7. Correct to 4 decimal place. I have to find it correct to 4 decimal place. This is the requirement over here. Now, in this one, I will not do it directly. Okay, I will take out my calculator. I will solve it by like this thing will be plotted. I will get my answer. I will take it to 4 correct decimal place. No, we are not going to do it like that. Basically, this thing and this thing are connected. How they are connected? First of all, they are written as two part of same question. Okay, that's why you will say that they are connected. Second thing, whole power 7, whole power 7. Over here they have asked for till 4 decimal place. Over here I have expanded it till 4 terms. So these are the things which you have to keep in your mind, that if questions are connected like this, it means this question will be solved not directly, but by using the answer of the first part. Now, how will you use the answer of the first part? What I have told you, this thing is connected. Why they are connected? Power are 7, power is 7. It is expanded till first 4 term. They have asked for 4 decimal places. We say that okay, they are connected. Okay, so what will you do? You will take this thing, 2 minus x over 2 equals to 1.995. I'm not even taking power 7 because power 7 will not be, if I will take power 7 over here and power 7 over here, that will also get cancelled. I have put this question by taking the values from here of x. I will take out the value of x, and that value of x will be plotted over here to get your answer. This is the main concept of this question. So now, okay, I'm writing power 7 and power 7 also. Okay, just for your understanding. So I have taken, I'm saying this thing and this thing is same, right? So I have written this whole thing over here, this whole thing I have written over here. Now what I'm going to do, power 7 and power 7 is there. So power 7 and power 7 will be removed. I will be having 2 minus x over 2 equals to 1.995. Okay, that's I have got. Now, what is the next thing I'm going to do? 2, I'm shifting this over here, minus 1.995, and I'm shifting this whole thing over here. Okay, I have to find the value of x. From this solution, I have to find the value of x, which I can plot in my this values. In place of this, I will be plotting, and I will be getting my result till 4 decimal place. That is the main concept over here. So 2 minus 1.995, the result is coming 1 over 200. This 2 is being divided, so when I will shift it over here, that will be multiplied. This is the thing. Simplifying it, 200. So the value of this one is coming 1 over 100 or 0.01. Okay, this is the value coming. Now what will I do? I have got my value of x over here. I have got value of x. I will take this value of x and I will plot it over here. 128 minus 224, 0.01 plus 168, 0.01 minus 70, 0.01. Now, this one was having power 1. Over here power is 2. Over here power is 3. Okay. Whatever was the power, I have written it over here. Power 1. X was power 1, so I have written power 1. X square, I have written power 2. X cube, I have written power 3. Now, 128 minus, when I will, this is coming 2.24 plus, this is coming 0.0168, and this one is coming 0.00007. Okay. Right? Now, when I'm going to simplify them, okay, 128 minus 2, 2.4 minus 0.168 minus 0.00007. When I will simplify it and I will write my answer, my final answer is coming 125.7767. That's your final answer. Okay, that is going to be your final answer.